Excellent. In this example, we're going to carry on with linear regression and have a look at some data about Bob, who is experimenting in baking a cake at different temperatures and comparing their heights. First of all, what do you think is the independent variable?
Well, Bob's going to change the temperature, so temperature should be the independent variable.
Okay. And the degrees are Fahrenheit. So temperature. The next thing is that we are going to create a scatter plot on the grid to the right, labeling the axes. Now we have picked a scale counting starting at 300 and counting 10, 20, and so on. On the vertical axis, the dependent variable of height, which will depend on the temperature, and it goes up to about 17.5, and it starts at about 14, so we counted every 4 to be, so each of those lines is 1/4, 0.25. So let's get the points on here then, and we will have the point 300, 17.4, so it's a little bit less than 17.5, and then 320, 17.3, so a little bit above that 0.25 line. No, to the right. Yeah, and get rid of that other spot there. And then we have 17.1 at 340, so just, yeah, it looks pretty good to me. And 16.2, seems like quite a drop there, just below 16.25. And then 380 is 15.1. And finally 400 at 14.8, so just over that 14.75 line. Excellent. So there's a nice scatter plot. And we did the labeling in advance. You might need to pause the video for a second and catch up. Next, we are going to use the GDC to find the equation of the line of best fit to 4 decimal places. I suppose that should say regression line, not line of best fit, because line of best fit we would do by eye. There is one mistake here. We are actually looking for temperature as a function of height. We mixed our independent and dependent up, so we fixed it on ours, but yours, you'll need to switch the variable h and t to match it up here. So sketch this onto the axis, and what we do now is go over to the calculator and stat. We want to move to edit and select this. We've already put the data in. Again, pause the video for a second, put your data in. Now that you've done that, press stat, go over to calc, linear regression number 4. It'll give you this drop down menu, so X list is L1, Y list is L2. We don't have a frequency, but let's go ahead and store the regression equation to make our life easier. We will press alpha, trace, and put it right away into Y1, so it'll graph it all at once. Then we press enter to calculate, and we will get the result. So y equals, and remember that we are asked to 4 decimal places. So y equals negative 0.293, capital T for temperature, plus 26.5667 to 4 decimal places. All right?
Should we change to H?
Yeah, H would be better, sorry. That's a good point, Mr. Song. There we go. H equals. Perfect. And what does the slope mean in the context of this particular problem?
So slope is change in y values over change in x. So that's how much the height is going to change for every degree. So the height of the cake is going to decrease by 0.0293 centimeters.
Perfect. All right, let's put that in a sentence. So the height, oh yeah, good, for every, So we like to refer to the slope in a sort of a unitary manner most of the time. For every degree, the height of the cake decreases, it's not very much, is it? By negative, yeah, that's perfect because we don't need the negative, it's decreasing already. Super. Excellent. All right, so carrying on to part D, on the next slide, we see what does the y-intercept mean in the context. This is a bit of a ridiculous question, isn't it?
Right. The y-intercept, because our x values were, or independent variable was temperature, the y-intercept means when the temperature is 0 degrees.
0 degrees Fahrenheit. Sorry, I think that's pretty funny.
Yeah.
Because 0 degrees Fahrenheit, you're not going to have much of a cake there. The model doesn't make much sense. So you have to be very careful with regression problems, line of best fit problems, statistics problems, with where does your model make sense and where does it not make sense. So the height of cake at 0 degrees Fahrenheit, which doesn't make sense. We could come up with a value, it's just completely, it's irrelevant. Okay. However, this does start to make sense because we're going to predict the height when it's baked at 330, and 330 is within our range of acceptable values. Because we've stored the regression equation, we can put our method point here, right? Height equals negative 0.0293. Now we can replace the t with the temperature of 330 and work it out. Plus perfect. And the calculator's got it stored, so we can go to the y equals menu and make sure our window is in a place that makes sense, or we could zoom stat because we've got some statistical data. That'll also work. Zoom stat, it's near the bottom. Oh, we didn't put the stat plot on. So second y equals, and there, and turn it on, and then zoom stat.
Oh no, it was 9, right? Zoom 9, I think.
Yep. Oh, 8.
Zoom.
No. Go for 9, press 9. Okay, super,
There.
okay. And what we want is to use this model. So you're probably thinking, guys, that was not very efficient. I could have typed it in my calculator. Yeah, you could do that in the operating menu as well. But we'll just show you something new here. If you now go to second calc, press the blue key and trace, and you put in value of 330, and press enter, then the model tells us that the expected height is 16.9. Okay, now we're going to predict the temperature if the height is 18. So again, our method mark comes from showing that we know that 18 is equal to negative 0.0293. Here's the temperature which we are going to find. And in this case, you could again, of course, do it algebraically, or we can graph the line 18, which will give us a nice flat line. And then we can find the intersection of these two things. Let's go to window, and we need to change our y max maybe to 19 or something around there. And because we won't, yeah, oh, do we see it? If you didn't see it, you might also need to adjust your x values as well.
Let's go 250 maybe?
250 sounds good. And would you trust your model here?
Well, 18 centimeters is outside of my data. So that's called extrapolating?
Extrapolating, yeah. Is it very far outside of your data like that 0 was?
No, it's not very far. So this would be somewhat reliable.
I think so.
17.4 to 18, not very big difference. Second, trace 5. First curve is y1, second curve is y2, and my guess is there. 292.5.
Perfect. And finally, we have a question about Bob's friend Sean, who bakes a cake at 370 degrees, and it rose to a height of 15.5. So we're going to compare what Bob's height would be with Sean's height of 15.5 and see what we get. So again, we're back to the value because we're inserting a temperature of 370. Now what we're going to find is Bob's, and we're going to compare that. So Bob's is 15.73. So whose is taller cake?
Bob's is taller, right?
Okay. So Bob. Okay, so therefore Bob's is taller. Perfect. What else do we want to say? Anything?
I think that covers it.
All right.